In this video, we're going to summarize what we've learned about distortion quantities by comparing all our distortion metrics at once. So here's a roundup of all our distortion quantities in one place. There are two interesting portions of the table. The first is the top half that notes that the harmonic distortion products are pretty tightly related to intermodulation products. Conveniently, you can remember that IM2 and IM3 are each bigger than their linked harmonic distortion by their order. So HD2 is half as big as IM2, or HD3 is a third the size of IM3. The bottom half of the table has the most important relationship to remember from this video, which is that IIP3 is about 10 dB above P minus 1 dB. We can find that most easily by comparing the VZP at IIP3 to the VZP at P minus 1 dB. They're related by a factor of the square root of 10 to the minus 1 over 20, which turns out to be 9.6 decibels. Because decibels are always ratios of powers, we can also say that IIP3 and P minus 1 dB are related by 9.6 dB. This relationship is really useful because we can measure P minus 1 dB while we can't measure IIP3. By measuring P minus 1 dB for an amplifier, you can calculate IIP3 and in turn find your third order intermodulation by backing off from it. You can also find your harmonic distortion power based on the relationship between IM3 and HD3. That makes this relationship one of the keys of interpreting amplifier datasheets. Because the relation between P minus 1 dB and IIP3 is so important, we're going to show another way to find it. We can also use our backoff calculation to show that P minus 1 dB is 10 dB below IIP3. We do that by letting our backoff be 10 dB and then showing that the third order intermodulation power would reduce the first order power by 1 dB. We're going to need to subtract our third order voltage amplitude from our first order voltage amplitude to do this, because powers don't add directly and dB definitely doesn't. So we convert our third order modulation power back into a linear scale and then back into a voltage. We're neglecting the system impedance in this calculation because all of these powers are created by voltages driving the same impedance, and every voltage is expressed relative to another voltage, so the impedance would fall out of the equations. We follow that up by figuring out how big 1 dB is. Reducing P out 0 by 1 dB is the same as multiplying it by 0.8. If we convert that into the corresponding 0 to peak voltages, we see that it's the same as reducing the 0 to peak input to 90% of its initial value. Finally, we bring these two calculations together to show the third order intermodulation, which is 0.1 V out 0, reduces the voltage output of the amplifier to 90% of its initial value, to 0.9 V out 0. That matches the voltage we expect from our P minus 1 dB calculation, so backing off by 10 dB from IIP3 puts us at P minus 1 dB. So in summary, IIP3 is about 10 dB above P minus 1 dB, and intermodulation is about its order times worse than harmonic distortion.